All right, this video is going to talk about what it means to be statistically significant. I'm also going to talk about p-values, and I also want to talk about how you would write your conclusions for a hypothesis test. I'll give you an example as well. So let's start off with, what does it mean to be statistically significant? Well, when we say statistically significant, that means that the sample that you've collected for your hypothesis test, which provides evidence, would be like this. If the sample you collect to provide evidence is a lot different than the parameter that you are testing, and I like to say that the parameter that we are testing in our null hypothesis, we are putting on trial, then you have evidence that is statistically significant. So if the sample, your evidence, is a lot different than your parameter, then then we would say it is statistically significant. So let's just pretend that let's pretend that our null hypothesis says that 20% of M&Ms are green. So the proportion of green M&Ms that the M&Ms company makes is 20%. The proportion of green M&Ms is 20%. Remember that when we get to our example. So now, how do we know if the sample or our evidence is statistically significant? You're saying that it's a lot different, Mr. Mays. So what does that mean? How different does it have to be? Well, there's two different ways that we can look at this. The first way we can look at this is to say that if your p-value is smaller than your level of significance, then your sample or your evidence is statistically significant. In other words, it's a lot farther away or a lot different than your parameter. So what is p-value? Well, I'll get to that in just a second. But if your p-value is smaller than your level of significance, which is called alpha, then you would say that your evidence is statistically significant. Well, another way that we could look at this is the classical method by using something called rejection region. So now I'm assuming that you know what rejection region is. If you don't, then talk to your teacher about that and we'll figure it out. But if your test, if your test statistic lands in the rejection region, then once again, your test statistic, which for proportions is a z-score, for means it's a t-score. But if your test statistic lands in something called the rejection region, then you would say that your evidence or your sample is statistically significant. Okay? In other words, it is a lot different or far away from the parameter, that you are putting on trial. So now, what do we do if our evidence, the sample, is statistically significant? Well, if your p-value is smaller than alpha, or if your test statistic lands in the rejection region, which means, like we said up here, it's statistically significant. So if your p-value is smaller than alpha, your level of significance, or if your test stat lands in the rejection region, then both of which mean that your sample or evidence is statistically significant, then you will reject the null hypothesis. That's what you're supposed to do. If we find, according to this up here, that our sample or our evidence is statistically significant, then you should reject the null hypothesis. Now you may say, well, why? Okay, I can understand that. I can follow those rules, but why do I reject the null hypothesis? Well, that goes along with what the p-value means. So let's talk about what exactly is the p-value. What is its definition? Well, this is my version of the definition. Your p-value is the probability of obtaining that sample or your evidence, or a more extreme sample, assuming that the null hypothesis is true. So if we are assuming that the proportion of green M&Ms is 20%, but we end up getting a sample and we get evidence, which is our sample, if we end up getting a sample that is really far away from that 20%, then we say that that sample is statistically significant, and the probability of getting that sample is really, really small. So if the probability of getting a sample of green M&Ms is a lot different than what we expected, then maybe what we expected is not true. Maybe we shouldn't expect that. So if we are expecting to open up a bag of M&Ms and find that 20% of them are green, but we open the bag and only one out of 50 M&Ms is green, well, whoa, that should lead us to say maybe the green M&Ms are not 20%. Maybe there's something different. So we would reject the null hypothesis that says 20% of the M&Ms are green. So let's go a little bit more detailed here. How do we know, or how do we know we use the p-value, or how do we use the p-value? I typed this quickly. How do we use the p-value in describing our conclusion? So here we go. Let's start like this. If the p-value is really small or less than your level of significance alpha, then it is statistically significant and we should reject the null hypothesis. So in other words, if the null hypothesis were true, then the probability of getting this evidence is so small that it leads us to believe that maybe the null hypothesis is not true, and therefore we should reject it. Okay? So what does that look like as an example? Well, let's take a look at this example right here. Let's pretend that I did a hypothesis test for these green M&Ms, and my null hypothesis said that 20% of the M&Ms are green, or the proportion of green M&Ms is 20%. How should we write our conclusion using the p-value? I think a good way to write it would look like this. And this is assuming, you got to assume a little bit here. I didn't do the entire test, but let's assume that the null hypothesis says that the green M&Ms are 20%, and we end up getting a p-value of 0.012. And let's pretend that our level of significance alpha is 5%. So how would this conclusion look? Well, here we go. A p-value of 0.012 says that if the true proportion of green M&Ms is 20%, then an observed value of 6% green M&Ms would occur only 12% or 12 out of 1,000 times. With a p-value so small that is less than our level of significance of 0.05, we will reject the null hypothesis. This does provide enough evidence to support our alternative hypothesis that says the proportion of green M&Ms is less than 20%. So in this conclusion, I would encourage you to pause this video and read this a couple more times. But in this conclusion, I am using the definition of p-value by saying if the true proportion of green M&Ms is 20%, in other words, if the true proportion of green M&Ms is 20%, there's the null hypothesis. If the null hypothesis is true, then an observed value of 6%, which is our sample, would occur only 12 out of 1,000 times. There's the p-value, 12 out of 1,000. The p-value is so small that it is less than our level of significance. So we will reject the null hypothesis. Then I go on to talk about the alternative. If I'm going to reject the null hypothesis, then I do have evidence to support the alternative. And that's why I end this by saying this does provide enough evidence to support our alternative hypothesis, which says that the proportion of green M&Ms is less than 20%. I would encourage you to watch this video 2 or 3 times, go back, rewind, whatever you got to do until you understand what it means to be statistically significant, how you use that knowledge or how you determine if something is statistically significant, and then also what is the definition of p-value and how do we use the definition of the p-value when writing our conclusion to a hypothesis test. Hopefully this will help you understand all of that a little bit better, and hopefully you have fun in your stats class.